Angles now, dealing with angles in circles. So you've got central angles, inscribed angles, intercepted arcs, all these kinds of things. You need to break these big pictures down into littler parts. So what do they tell us? Let's see, sides BA and CD are extended to P, diagonals. A lot of this isn't real important. This is the first piece of very important information here. Measure of AD to measure of DC is 1 to 2. So what do you do with that? When you have a ratio of 1 to 2, you're going to say AD to DC is 1x to 2x. 1x to 2x. What else do we know? ABC, this whole arc, is 234. So ABC is 234 degrees. And BC is 54 less than twice the measure of AB. BC is 54 less than twice AB. So that means this piece here is 54 less than this piece, twice this piece here. How do we handle that? Well, we're going to call ABX. That's going to make BC 54 less than twice that. So 2x minus 54. Okay? We need to start solving for some things here. We're not ready to solve this ratio yet, but we can get x. If you look at these two, we know that this whole arc is 234, and we know that this piece is 2x minus 54, and this piece is x. So we can write 2x minus 54 plus x equals 234. Combined terms, 3x minus 54 equals 234. That means 3x is equal to, if you add 54 to both sides, we have 288. We need to divide that by 3. Well, let's see. This is 12 less than 300, so it's going to be 4 3's less. So this is going to be x equals 96. 3 times 9 is 27, plus 3 times 6, which is 24. 3 times 6, which is 18. 270 plus 18 is 288. So x is 96. That means we can come over here and say this is 96. And we can say this arc is 96 times 2 minus 54, or 234 minus 96. Either way, we should get 138, I believe. Let's see, 96 plus 4 gets you 100 times 34. Yes. So this becomes 138. Now, just since I can erase this, I'm going to replace these numbers here because it's a little confusing. I'm going to take this x out, just label that 96. I'm going to take this 2x minus 54 out. Just label that 138. Okay? This way we can see that CB is 138, AB is 96, and we go from there. So now we're in a position to figure out what x and 2x are. Right? There's something I did here that was a mistake. And I wish I hadn't erased that because now I see it. But be careful here. Before I said this was x, and this was 2x minus 54, right? That's fine as long as I don't also call these x, because this is a different x. So let's now take this, and now that we have these degrees, we can go after these two. But notice this is a different x. I should have called this a different variable, maybe y, or left it out until now. Now that I have this, I can figure out what these add up to. I've got 234, right? This piece has to be 360 minus 234. So 360 minus 234. Well, you know you have 100. 34 up to 60 is 26. So this here has to be 126, right? The difference between 360 and this one. So we can say x plus 2x equals 126, which means 3x is 126. So x is 42. That's this x over here. So this guy's 42 and this guy is double that. So we'll replace these with numbers as well. 42. And this one's going to be 84. Okay. So let's see what we have in terms of answers now. Measure of arc AB, that we got, 96. Measure of angle ABD. Well, angle ABD is this angle here. It's an inscribed angle. It intercepts this arc. So it's half of 96, which is 48. Measure of angle BPC. BPC, this angle is outside of our circle, right? We're looking for this angle now. How do you find the measure of an angle outside a circle? 1/2 the difference of the intercepted arcs. So you look at your angle, what are the intercepted arcs? BC here, AB here. So measure of angle P is equal to 138 minus 42 divided by 2. 138 minus 42 is 96. Measure of angle P is 96 over 2, which is 48. So this guy here, also 48. It seems a little high. Did I get that right? 138 minus 42. Yes? Okay, so we're 48. Angle AEB. AEB, this guy, well, this is an angle inside of a circle, right? So this is 1/2 the sum of the intercepted arcs. 1/2 the sum. So we need to look at the two intercepted arcs, 96 and 84, add them together, and split it by 2. So let's see, I'm running out of room a little bit here. I guess I can get rid of this stuff now. So let's see, I have pretty much done with you. So we'll get rid of it. Done with you. Get rid of it. Ah! I don't want to do that. You go back. Rookie mistake. So these over here, I'll just take them out. And good. Now I've got a little bit more room to work here. Okay. So we're going to have to measure angle AEB, this guy. So measure of angle AEB equals this arc, 96, plus this arc, 84, over 2. That means it equals 96 plus 84 is 180 over 2. So it's 90. So we've got 90 degrees there. And we've got one left. Measure of angle ADP. ADP, this angle here, this one isn't a special angle. It's not a particular type of angle. It's not a tangent to secant or anything like that, or excuse me, tangent to chord. It's just an angle. So the easiest way to find it is to go after its supplement. That angle there. ADC, that's just an inscribed angle. Not much going on. Intercepts this big arc, 234. So it's half of that, which means angle ADC is half of 234, or 117. Well, if that's 117, then ADP, which is the angle that we want, is its supplement. So it's got to be 2063. Okay? So as you can see, there's a lot of work going on with one of these problems, but it's just one piece at a time. You got to walk your way through it, step through it. So let's take a look at another one similar to this one of these big circle problems. Always start by reading what you have. All right, go through the information. In this circle, diagram of O, AE and FD are chords, great. AOBG is a diameter, that could be useful, right? Diameter split circles in half. CDE is a secant. AE, this means parallel to FD. The font isn't loaded in the computer properly. So this is parallel to FD, okay? In other words, this line here, AE, and this line here, FD, parallel to each other. And then AE to ED to DG, 5 to 3 to 1. So let's start there. Take that ratio, 5 to 3 to 1. AE, 5x. ED, 3x. DG, x. What do you notice about all three of those? What do they add up to? diameter, right? So this is 180 degrees. So 5x plus 3x plus x is 180. Collect some terms. 5, 8, 9x is 180. So x is 20. Okay? Let me take these out of here and we'll put the degrees in. X is 20. That means this arc here is 20 degrees. This arc here is 60 degrees, and this arc here is 100 degrees. 160, 20. So let's take a look. We already figured out one piece. It wanted to know DG. That's 20. Angle AEF. AEF, where's F? Down here. So this is over here, right? This is an inscribed angle. It intercepts AF. We don't know what AF is, though. How are we going to figure this out? Well, remember these lines are parallel? If you see parallel lines, what kind of angle should you be looking for, thinking about? Hopefully you're thinking inscribed. So if you look at these pictures, or this picture, you can notice, for example, that this angle here and this angle here are alternate interior angles with these parallel lines. If you can't see it, then I give it one of those. These are alternate interior, which means they're congruent. Well, this intercepts this arc, ED, and that angle intercepts AF. So, congruent angles intercept congruent arcs, right? Congruent alternate interior angles intercept congruent arcs. So, if that's 60, that means this one is also 60. Right? This angle intercepts that 60, this angle intercepts this arc, so it's got to be 60 as well. So that means angle AEF, the inscribed angle, is half, which is 30. Next we're looking at angle DBG. Angle DBG. So this is this little angle in here. It's kind of hard to see, but let me do this. If I say DBG, this is the angle we're looking for, right? If I pull it out, this is the angle we're talking about here. Maybe if I do it in a different color, even better. How about red? This is the angle we want, DBG. Right? This guy. Okay? So how are we going to get that? What kind of angle is it? That's an angle formed by two chords, isn't it? Right? So this angle formed by two chords, what are the intercepted arcs? 20 and 60. So to find DBG, we have to look at half the sum of those arcs. So measure angle DBG is equal to 60 plus 20 over 2. Half the sum of the intercepted arcs. That means it's equal to 80 over 2, which is 40. So this angle, 40 degrees. Next is DCA. Well, DCA, let me pull this out of here so you don't have to look at it now. DCA is this angle here, right? It's an angle outside of the circle. So you've got to look at the intercepted arcs. Here's one of the pieces. Here's the other piece. So what arcs are we intercepting? We're intercepting 100, and we're intercepting this little 20 right here. So it's outside the circle, which is 1/2 the difference of the intercepted arcs. So you do measure of angle DCA equals, get a little high again, 100 minus 20 over 2. Which is 80 over 2. Which once again gets you 40 degrees. Finally, they're asking us to find angle CDF. CDF. Well, that angle is a little bit tricky. All right, let me just grab these out of the way again. Drop it down there. So CDF this angle isn't really any one of our special angles, right? It's here and here. So this isn't inscribed, right? It isn't a tangent and a chord or anything like that. It's just an angle. So you want to look for either a triangle or a supplementary angle. In this case, I'm going to go supplementary again. Check this out. That angle is supplementary to the one that we want, right? The one that we want is here, so it's supplementary to this green angle. Well, that green angle is just inscribed. What arc does it intersect? 160. So the green angle is half of 160, which is 80. That angle is 80, which means the angle that we want, this guy, has to be 100. So this is 100 degrees. And that's it. That's our problem. So again, you're using all the different types of angles in a circle, just stepping through them one at a time. Look for ratios, look for equations that you can set up. Since this one was on the smartboard, you can go to my e-board and I will post the PDF of this whole thing for you so you can take a look at that if you're in my class. If not, that's the website of my e-board if you want to check it out. That's my school website. And as always, thanks for watching. Please leave some feedback. If you like what I'm doing here, go to iTunes, give me some suggestions. If there's anything you'd like me to see, send me an email. Good luck on the test Tuesday. Have a great day.